Hello, everyone. Hello, how are you?
How you
Hello,
doing,
how are
Professor?
you?
Hey, how's it going, Professor?
I'm doing good. How are you? Can you all hear me?
Yes.
Yeah. Yes.
Oh, good. So, yeah, I decided to have this as a virtual. Something came up that I have to take care of. There is an emergency, so I had no choice than to make it a virtual class. Now, before we start, I want to show you what we have this week. The announcement I made about this week. This is week 8. You can see from here, week 8 activities and assignments. So we are on the lecture 5, which is probability distributions. And then there's a week 8 assignment, which is classwork 7 for tonight, and homework 4, which will be on probability. If you remember, we finished probability last week. Now we are on probability distributions. Okay. Next thing I want to show you is this file. It is called Statistical Table. From now on, we'll be using it. So I recommend that you print it out and keep it handy, because starting from tonight, we start to use it. I think it's right. Let me see, give me 1 minute. Right, I think it's free. Statistical Table is right there. So download it and print it. We're using it from tonight. I've already downloaded my own, and I'm going to show you how it looks like. It looks like this. It have many distributions, like this one that we'll be using tonight. It's called binomial distribution. Now, after that, next week, we start to use this type. Areas under standard normal distribution. Then we go from there. So download them, download the file and print them out. You also need them for other tests. We still have 2 tests left to do. So now let's start the class. If you have any question, you can ask me at the end of the class. Okay. Hello.
What was that, Professor? What was that?
Yes, if you have any question, you can ask any question, any concern, you can ask me at the end of the class. But
Okay.
Have any question with what I'm teaching, you can always ask me as I'm doing it. Like I said, today what we have is the concept of, actually this should be supposed to be discrete. Discrete probability distributions. That's what it's supposed to be. So for tonight, we'll be covering random variable, discrete random variable, continuous random variable, and then after that, we can now look at one discrete probability distribution, the one that we call binomial distribution. So the other type, like Poisson distribution, but we will stick to binomial distribution. So let us start with the first concept, which is random variable. I'm sure you must have we have come across this before when we were doing, well, at the beginning of the semester. I think we described types of variables. Now, we'll be looking at random variable. A random variable is any variable whose values are determined by chance. Just give me 1 minute. For example, the values of a random variable, it's a chance variable. If you look at it, we use X to denote a random variable. For example, if you say that X represents the number of calls a salesperson makes in one day, so that means that person can make 1 call, 2 calls, 5 calls, 20 calls. You have no control over that. So it's a random variable. How about this? The time the buses arrive at a bus stop. I know they have specific time, but sometimes they arrive maybe 5 minutes early or 5 minutes late or 10 minutes early, you know. So it can such arrival time can be considered random. And there are many more examples of random variables, but we come to them as in a few minutes. Now, next thing is the what we call discrete random variables. Now, these ones they are so called because of the fact that they are countable. For example, you can count the number of sales calls that a salesperson make. Let me show you my example of this discrete random variable. I think I have many of them here. Okay, I'm gonna make this bigger. Okay, from here you can see more discrete random variables. See, number of joggers in a Patterson Park, for example. You can say there's only 1 person jogging, 2 persons jogging, you know, and so you can, because you can count them. Number of eggs laid by a hen in 1 day, you know, you can count them. Number of telephone calls received after a TV commercial, you can also count them. Now, but for the continuous random variable, you cannot count them. Instead, you can measure them. They are measured. So they has an uncountable number of possible outcomes that can be represented on an interval. For example, how many hours spent on sales calls in 1 day? You cannot count hours, but you can measure them. So that's why I call them continuous random variable. So more examples of the continuous random variable, that things that you can measure. You have things like temperature. See, temperature, voltage, height, all these are continuous random variables. So now we have examined the meaning of discrete random variables and continuous random variables. Now we are ready to define the ask a few questions about those variables. Look at this question. It says, decide whether the random variable X is discrete or continuous. Here, S represents the number of Fortune 500 companies that lost money in the previous year. Now, you can count the number of companies, so it is discrete. See? Because you can count them. You can say that no company lost money last year. 1 company lost money last year, and only 2 companies lost money. So you can count them. Now, but if it is continuous, like this one, decide whether the random variable is discrete or continuous. Where S represents the volume of gas in a 21-gallon tank. This one is continuous because you can measure them. You cannot count the volume of gas, but you can measure them. So now, with this background, we are now ready to explain the main thing we have today, which is the discrete probability distributions. Now, the simplest way to explain the discrete probability distribution is that it consists of each possible value that a random variable can take or can assume, then together with their corresponding probabilities of those values. So I'll show you my examples from here. So each values and their corresponding probabilities. If you look at this here, you can see the number of balls we have here and the corresponding probabilities. So the values each of them can take and their corresponding probabilities is what makes them a discrete probability distribution. 2 assumptions we make here that the 2 qualities or features that the probability of each of the values of the variable is between 0 and 1. So it cannot be less than 1. That means they cannot be negative. They cannot be greater than 1, but it can be any number between 0. So you can have 0.52, 0.21, 0.05, but you cannot have 1 point something. See? So another one is that the sum of all the probabilities equals 1. So if you add all the probabilities of a discrete probability distribution, they'll give you 1. So now I will show you an example here. Okay. If you look at this, what we have here, it says determine whether each distribution is a probability distribution. Remember the rule, 2 requirements that I just explained. Those 2 requirements are that the sum of the probabilities of this in the sample space must equal 1, and that the probability of each event in the sample space must be between or equal to 0 and 1. So based on that, look at this one here. It says determine if either or any of them is a probability distribution. How do we know? We add their probability to see if that equals to 1. So that means we have some of these probabilities, some of px, which you can write as spx. So each of these probabilities is 1 over 5. So we have that sum of px will be written as this. Let me go to our formula page. Excuse me, I'm going to show you this before we can go there. There are 1, 2, 3, 4, 5. We'll write them down. There are 5 of them. So that the sum of px just 1 minute. Sum of px equals sum of px becomes 1 over 5 plus 1 over 5. Then what I'm going to write, I'll write it down. 1 over 5. So we have it in this place. That's sum of px. 1 minute. So that we have the insert equation. So that we have sum of px. Okay, sum of px. That is sum of all the x is there. It becomes 1 over 5. In order not to waste time. So sum of px, let me put it this way. Sum of px, what I need. I'll put this up. Becomes equals 1 over 5. Okay, plus 1 over 5 plus 1 over 5 plus 1 over 5. There are 5 of them. 1, 2, 3, 4, 5. So plus 1 over 5 equals. So I can make it bigger so you can see it better. So now let's add this. We can add it by going to our calculator. Our calculator is somewhere. What is my calculator? It's gonna be somewhere. Okay. I think I opened so many things. Right here. That's my calculator right there. So we have sure. Come on, Desmos. Okay. Can you see the calculator? Can you see the calculator, class?
Yes, sir.
So 1 over 5. 1 over 5. Okay. Plus 1 over 5. Okay. Plus 1/5 plus 1/5. Okay, plus 1/5, 1/5. You can see that they add to 1 equals 1. So that is the first requirement. As you can see here, they add to 1. So the answer is yes. Yes. It is a probability ability distribution. Questions? Any question? So no question. Good. So it satisfied the first requirement. The second requirement says is that the probability of each event in the sample space must be equal. It must be between or equal to 0 and 1. This means that the probability can never be negative, and it can never be greater than 1. So look at the second example. Second question here. It says, is this a, it says, remember, it said that determine whether each of the distribution is a probability distribution. Is this one a probability? So let's see solution. So you have it in this form. So if you say, we look at it already, one of them is negative, which violates this rule here. This rule says that they can never be negative. So it is not. And this one is bigger than 1. So the answer is no, because one of the probability values is or has a negative value of -1.0, and another one, okay, has a 1.5 probability value, which is bigger than 1. So because of that, it is not a probability distribution. So it violated the second rule. Now, how about this one? Is it a probability distribution? Let's see if it is. I don't know. So the only way you can know is to add this. To add all this. That means we're gonna have 1/4 plus 1/8 plus 1/16 plus 9/16. Let's see. Let me write it down so we can add them. 1/4 plus 1/8 plus 1/16 plus 9/16. If they add to 1, that means that it satisfies the first rule, which says that the sum of the probabilities of the event in a sample space must equal 1. Yeah. So now let's add them. We have to make it bigger. Make it a little bit bigger so you can see that properly. So we have this, and then adding it, we're gonna have clear this. So the first one is 1/4. Okay, plus 1/8 okay, plus we got 1/16. Okay, plus 9/16. See, they add to 1. They all give us 1. So the answer will be 1. So that means it is yes. It is a probability distribution. Yes. It is a probability distribution. Because the sum of the probability, because the sum of the probabilities, because the sum of the probabilities equals 1. Equals 1. So because the sum is equal to 1, so it is a probability distribution. Any question before we move on to the next stage?
No.
No question. Okay, good. Now, let us see how we can construct a probability distribution. First, we said let X be a discrete random variable, which is with possible outcomes, X1, X2 to all the rest. So to construct it, first of all, we'll make a frequency distribution for the possible outcome. Then find the sum of the frequencies. And then, of course, find the probability of each of these outcomes. Then put them side by side. So the outcome and their corresponding probabilities give us the distribution we're looking for. Now, next thing is to check to make sure that it follows the law of this distribution set. So let's look at this first example. It said, industrial psychologists administered a personality inventory tests for passive aggressive threats to 150 employees. Individuals were given a score of 1 to 5, where 1 means extremely passive and 5 means extremely aggressive. And the score of 3 indicated neither threat. So the question says here, construct a probability distribution for the random variable X, then graph the distribution. So say to construct it, then graph it. So to construct it, we are given this, so you can see from here. We are given that the score and the corresponding frequency. When you add all of them together, you get 150. So next thing is to get the individual probabilities. So let me write this down and then we do it together. The score X, then probability of the scores. We have the score 1, 2, 3, 4, 5, and total. Then we have score and then frequency. The frequency. Okay. Okay, then I'm going to write 24 for this, for the score 1, 3 for score 2, and 42 for 3, 30 for 4. Okay. Then 21 for 5. So I'm going to put them, once you have this, then we get a corresponding frequency. So let me put total frequency. Let me take you to our workbook so we can complete this. I think it's here. So we come here and to construct it. So we come here and have this score. I'm going to put it together with 3 columns. 1, 2, 3. Okay. So you have the score. Score X. Then frequency. Yeah. which is F. Then, of course, probability X. Probability of X. Px. Px. The scores that I'm talking about here includes score of 1. Not having a 0 there. Okay. Yeah, there's no 0. So score of 1. Let me see. Two, 3, 4, 5. Then we do it together our total. Total. And frequency is giving us 24, 3, 2, then we add all of this, add all these numbers. Make sure I have everything right. Okay, let me see. Center 8. Okay, look at the probability. If you add all this, you add 24 plus 33 with a calculator, and then all of them get 150. So let's get the probabilities. Each of them divided by 150. So the probability will now become 24, for example, 24 by 150. You can see where they did it here from this paper. And see what they did, each of them by 150. See, 24 by 150 give it 0.16. You can see 24. So 24 by 150. 50 give me 0.16, and I can see it written here as 0.16. Okay, 0.16. So if you do it for 2, you divide 33 by 150. Each one divided by 150. So that's what I have here. I'm going to do the first one, and I'm going to enter the rest of them for you. So PS 0.16, 0.22, 0.28, 0.20, 0.14. Okay. So each of them, if you do it as 3 by 150, you get that. So they put it here, so you can see where I have it. 150, I get 0.16. And 33 by 150 is going to get 0.12. Then 42 by 150. 0.28. 30 by 150. 28. Okay, 2.28. You want like 1 minute, let me check something here. Yeah. Let me see. I want to check something here. Okay. Okay, for 4 is 20, and 3 is 28. Okay. 4 is 20. Okay, 4 is 20. What did I miss here? I think I missed something here. 4 is 28. Actually, this one is 20. I'm gonna double check this. 30 by 150. So I'm gonna double check 30 by 150. Okay, we got 30 by 150. 0.2. So it's correct. 30 is 0.2. And 21 is 5 is 21 figure, which is 0.14. Let's try it. 21 about 150. 21 by 150. 0.14. So this is the what they say probability distribution. This is the probability distribution we're talking about here. See, this is it right here. You can see 0.14. And to see if it is actually true that it is a distribution of that type, what you have to do is to add all the given probabilities. So let's add them. You can see that 0.16, yeah, 0.16 plus 0.22 plus 0.28 plus 0.2 plus 0.16. See, is approximately 2. Let me see what is missing here. Sorry, approximately 1. 0.28. So it should be 1 exactly. But 1.02, say 0.14. Okay. 0.124, 0.16, 0.22, 0.28, 0.20. So it's approximately 1. If you add them, you can see that here. Add them will give you 1. So mine, maybe I rounded up something. I typed something wrong here. 0.16, 0.22, 0.28, 0.20, and 0.1. Oh, I put 16, so 14. 0.14. That gives me 1 here. See, it's 1. So that means that it is a probability distribution. You can see that mine here. And you can see, so 1.00. So this is the score and their corresponding probabilities, which is PX. Question, please? Any question? No, okay, good. So now we are ready to draw the graph of this distribution. Let us draw the graph of it. The graph of a probability distribution. So to draw the graph, we're going to enter this in the graphing tool, or we can use a pencil and paper. So let's do it on this one. For Excel, we can enter them manually. So we have this. So I have this place. I have the score X. Then PX, the probability of X. Okay, make it bigger. PX. And the score is 1 to 5. And the probability of S to be 0.16. 0.22. 0.28. 0.20. 0.14. This is what you're going to graph. Let's say you can grab this. SAT, recommended graph. So it's making it multiple batch, so you can use that. So you can tweak this thing a little bit. So one, I can write it 1.00, 1 point dot dot. Okay. 2 point dot dot. Okay, I'm here. 2 points. Okay, 3 points. 4 points. This is a trick I use for say if you start making this kind of thing. That almost always works. So you have it here. Okay. Now let's use it to draw the histogram for that. We can use this. And remember, this question is about the survey responses for passive aggressive threats. Okay. Now, so survey scores. You can have it that way. Okay. So let's see the graph now. So survey score, I'm gonna add the axis. The score X. Score X and the probability. Okay. Probability. PX. PX. Okay. Now we can now response that they have a response. Okay. Now you can make these numbers to this thing to be together. Just format data series, and then move the gap down. Gap level. And just put it here and keep going down, so that it can fill the gap. Yeah. It's going. So when it is up to 50, that means you start slowing down. You can see, just keep clicking on the gap. Start going out now. Okay. This is required graph. So once you have done the graph, especially if this is a project, you can click on it, can copy it. Go to your writing materials. Okay. And then paste it here. See, that's the graph right here. Any question? Any question, class? Hello?
No, sir.
Questions?
No question. Okay, good. So now that is the graph. So now we can now look at the mean, variance, and standard deviation of a probability distribution. Okay. So please, if you want to ask questions, ask to me. I don't answer. I don't do chatting while I'm teaching at the same time. Okay. Now let's see this. So we have this. Find the mean, variance, and standard deviation. So I'm going to summarize it with on this page. That the mean, variance, and standard deviation of a probability distribution. Let me move this down so that we can get this. Okay, good. The mean, variance, and standard deviation of this distribution. Now, I'm gonna put the formulas here. So the mean, let me see if I can extend it. I think our time is coming to an end. So I want to, we have a short break when it comes anyway. So let me just continue. So the mean, let's see the other workbook. The mean okay, give me 1 minute. So the mean is this. Mean equals and of course, you know that the symbol for mean is the mu. The mu right there is sum of x times the probability of x times px. I mean, so I'm going to use for this time. I'm going to use for steroids times px. That's the formula for the mean for a probability distribution. The mean is sum of x times probability of x. You can see right here. Now, for the variance, there are two different methods you can get it, but let me use the shortcut method for variance. Variance will be variance, which we use delta squared to represent. I think I'm going to prove this first of all. So we use delta squared to represent that. Variance would be, okay, equals sum of x squared times px. This is the shortcut formula I use to give you the same result. Sum of x squared, okay, times the probability of x minus mean mean of mean squared. Okay, square. So I'll give out the variance right there. Okay. All right. This one will give out the variance. I'm going to put it under this one. So x squared times px. So this is then standard deviation, as usual, is the square root of variance. Standard deviation, which we use delta to represent, equals to the square root of variance. Any answer we get for variance, we square it to get the standard deviation. Okay. So once we have this, we can get the variance. Okay. Put it right here. I mean the standard deviation. Okay. Now, these are the things we can be doing now for an example here. This example, we're going to use this example we have here to find the mean, variance, and standard deviation of a distribution of this type. So, suppose we have this equation here. It says, okay, this is the question. It says, find the mean, variance, and standard deviation deviation. Deviation, okay. Okay, and the mean, variance, and standard deviation of this. Okay. So to do that, we have our px already. So I'm going to remove this. We have our px. So we're going to get two things. We're going to get x times px. So I'm going to insert two lines. See, x times px. Oh, excuse me, a mistake. I got it here. And then here. Okay. Now the insert. So I'm going to make this bigger. Okay. So that's x times px. So I already have all this multiplied. You can see x times px. Then we have to get x squared, then x squared times px. So let me make sure that this space will contain all this. I think I have to extend this time so that we can finish this on this time at the same time. Okay. Let me see if I can extend this time on the Zoom. So the video. Let me see if I can extend the time. Let's see. Okay. So time is almost up. Okay. Let us be working on put these numbers in. Let me put it set up the table. Then I will, because it will cut us off at in the next 8 minutes. But I'm gonna put it back again. It didn't allow me to have a 2-hour stretch, so that's why it's 1 hour in between. So when it cut us off, we have a 10 minutes break. So I put it back, and we log back. You're gonna log back in. Go to the same place you went today to log back in after 10 minutes, and we finish this up. Okay. So let me just put the numbers in our table. So we have x squared times px. One is x squared times px. Now, this is what we're gonna fill this table, these 3 columns. Once we fill up these 3 columns, and then we can now finish up. X squared times px. This is x squared. X squared times px. So I'm gonna make this a little bit bigger so you can see this properly. Okay, now x squared times px. Okay. Okay. Times px. Okay. Now, for x times ps means this one here. Gonna be here. I'll make sure you're seeing it. It's gonna be this one number here times this. This is 0.16. 0.16. Yeah. So for this one, it's gonna be 1 times 0.16 give us 0.16. 2 times this give us 2 times 0.12. 2 times 0.12. What is it? What is it? What is my calculator? 2 times. Okay. 0.12 give us 0.24. So we go there and put 0.24, 0.24. So you follow the same process for all of them. So I'm gonna put all of them in 3 times 0.28. So we have 3 times 0.28. Okay, 3 times times 0.28. Give me 0.84. We get 0.84. Okay, 0.84. Then 4 times 0.2. Get 4 times 0.2. 4 times 0.2 is 0.8. We got 0.8 on it. 0.8. Then last one is 5 times 0.14. 5 times 0.14. Okay. 5 times 0.14, 0.7. That's 0.7. 0.7. So when you add all this, that will give you the mean of the this. So, but let us get everything there. We'll get it. So, because like I said, I'm using a summary, a shortcut formula. So now for this one, we have square s square. That means you're gonna square all these numbers. So 1 square give us 1. 2 square means 2 times 2, which is 4. 3 square means 3 times 3, which is 9. 4 square means 4 times 4, which is 16. And 5 square means 5 times 5, 25. So now we're gonna like I said, this is giving us only 1 hour. So we have only 3 minutes left. So I'm gonna close it now. Then log back in the same place we log in tonight in 10 minutes time, so that we can continue and finish this up. Okay. Hello.
So you want us to leave and then come back in 10 minutes?
Yes, because this will
Okay.
not log us back. So let us have a 10 minutes break, then log back in the same place you log in tonight. Okay.
Okay.
All right. I see you in 10 minutes time. Yeah, so we can finish this. All right. Okay.